Alright, this next set of notes is over volumes, and we're going to be covering the volumes of all the three-dimensional shapes that we've already been talking about. The first are prisms and cylinders. And when you look at the formulas for prisms and cylinders on the tax formula chart, they're going to be the same thing. It's going to be for a cylinder base times height, and the base is a capital B, and it will be the same way here as well, base times height. What I did is I went through and I said, okay, this capital B and this capital B represent two different shapes. In a cylinder, it's going to be a circle, and the capital B stands for finding the area of a circle. So what I did is I went ahead and wrote out pi r squared times the height. All right. Down here in a prism, this capital B could be any polygon shape. So in this case, it's a rectangle, so I have length times width. In this case, it's going to be a hexagon, a regular hexagon, so its area is going to be perimeter times apothem divided by 2. So there are some, even though it's written the same on the formula chart, it's going to be prepared differently. So let's start off with the cylinder, where we need to know the radius and the height. And remember, the height is always the distance between the two bases. So this is going to be pi 4 squared times 10. This would be 16 times 10 is 160. So you've got 160 times pi, and you get 502.7 meters cubed. Remember, since we're talking about volume, we use the cubic sign, to the third power. All right, now then, and I'm using the pi button instead of 3.14. Tax will sometimes ask you to use 3.14. I use pi for simplicity's sake. The symbol, it's basically a choice. Your answers will vary somewhat, but not enough to get a wrong answer. All right, so now then, the volume formula, pi r squared h. The radius is 6. It is half the distance right here, so it would be 6. And the height would be 6 right here. Notice, even though this is laying on its side, that the height is the distance between these two bases. All right, so we've got pi 6 squared times 6. So 6 squared is 36. 36 times 6 and times pi would get us 678.6 feet cubed. All right, now then, for the prisms, right here, this length times width on the formula chart would be a capital B. So our length and our width are 9 by 24. Our height is 33. So we're going to plug all those numbers in. 9 times 24 times 33. And we get 7,128 feet cubed. Now this is going to be a little trickier. When you've got a regular polygon here, we're going to have to use the apothem. Okay, so the area of this one would be perimeter times apothem divided by 2 times the height. This would be the area of the base. This would be your capital B, and this is your height. Where our height is right here. It's the distance between the bases. Our perimeter is 10 times 6, so that would be 60. Now to find our apothem, we're going to draw an apothem starting from the center of the hexagon perpendicular to the side. We'll draw a radius, and remember that creates a right triangle. And our central angle here would be 60, because 360 divided by 6 would give us 60. When we draw the apothem, we cut it in half. So that angle is 30 degrees right here. That means this is our short leg. Our short leg is half the distance across this hexagon right here. So this would be 5. Because each side of the hexagon is 10, making half of it 5. That's our short leg. Our apothem is our long leg. It would be 5 square roots of 3. Because it's a square root of 3 times greater, we have a special right triangle of 30, 60, 90. So we have 60 times our apothem, 5 radical 3, all of that divided by 2, times our height of 12. So this is a little bit complex. I'm going to go ahead and divide this 60 by 2 and have 30. 30 times 5 is 150. So I'm going to have 150 square roots of 3. Close that parenthesis and multiply it by 12. And that would give us 3,117.7 centimeters cubed. Okay, that took a little bit of work there for that one. Now, volume of pyramids and cones. These, the cones is what we're going to start off with. But what I want you to see here is you see pi r squared h divided by 3 on the TAGS formula chart. That's going to be a capital B times h divided by 3. And your capital B is pi r squared. It's the area of the base. It's the area of this circle right here. All right, so we're going to write pi r squared h divided by 3. The r is 3 meters, so pi 3 squared times the height is 5. Now notice that h is height. That is the distance that's perpendicular to the base. It's from the tip to the base. This side here was called your slant height. This is the actual height of the cone. Alright, so when we get all of that, we're going to divide it by 3. So we've got 3 squared, which is 9, times 5, which is 45. 45 divided by 3 is 15. So that would end up being 15 pi, which is 47.1 meters cubed. All right. One more. All right, we are going to need pi r squared times height divided by 3. We've got our slant height, which is 10. We've got our diameter, which is 12. So if we are to draw our radius, we're going to have 6. And if I were to draw my height, I've created this right triangle right here. And I've got a hypotenuse that's 10, a leg that's 6. And if you recognize those numbers, this is a 3, 4, 5 right triangle whose digits have been doubled. So 3 has been doubled to 6, 4 doubled would be 8, 5 doubled is 10. So now I know that my height is actually 8. So pi r squared times height, all of that divided by 3. So I'm not doing this one in my head. I've got 6 squared, which is 36, times 8 times pi divided by 3 would give us 301.6 feet cubed. All right. Now, that same formula that looks like this is going to be used back here on the pyramids. Okay? Now, this thing right here only works if your base is a square. Sometimes our base could be a triangle. It could be a rectangle. It could be an octagon. It can be a trapezoid. It could be any shape, any polygon. So the generic formula is base times height divided by 3. Normally, they're square bases. That's the norm that you see, but you can have some that are a little different. All right. So again, this capital B depends upon whatever the area, the shape of the base is. That determines which area formula we'll use to find it. All right. So the volume, this is a square pyramid. So we're going to find, we need the side of the base squared, and then that's the area of the base, times the height divided by 3. So our side is 12. Our height right here is 15. divided by 3. So this would end up being 144, and 15 divided by 3 is 5. So let's go with 144 times 5, and we get 720. So 720 feet cubed. Write that formula again. Side squared times height divided by 2. Our side here is 10. Our height, we don't know our height. Oh, we've got our slant height, which is 13. And this little side of this right triangle here that's formed inside, this is half the length of the side. So since this side of the square is 10, this is 5. So this is another special right triangle, a Pythagorean triple, and it is a 5, 12, 13. If you did Pythagorean theorem, be sure you subtract 5 squared from 13 squared, and then you'll get a length of 12. And then, so our height is 12. Divide this whole thing. Holy cannolis, I just noticed something. I put a 2 up here. I hope y'all caught my boo-boo. Trace over that. That's supposed to be divided by 3. Alright, so now we've got 10 squared, which is 100. 12 divided by 3, which is 4. So this is 100 times 4 gives us 400 inches cubed. Who needs a calculator? We got this. Alright. Last but not least, you got volume of a sphere. Not a spear, but a sphere. Alright, so our formula is 4 pi r cubed, and I'm sorry that that's blurry and you can't really see that 3 there, divided by 3, where r is the radius. And again, when we did surface area, I talked about this. The radius is always from the center to the edge. There can be a radius drawn anywhere. A diameter goes all the way through the center, and the circumference is a great circle, which is like that goes all the way around a circle. Alright, so we're going to plug the numbers into our formula that we need. The only thing we need to find or have is the radius. Everything else is done for us. So our radius of this first circle is 3.5. So we're going 4 pi 3.5 cubed divided by 3. I'm not doing that one in my head, I'll tell you that much. Okay, so 4 pi 3.5. Now, to tell it to cube it, we're going to have to hit this little mark right here. It's under the clear button. And then you're going to hit the number 3. And it will only take 3.5 to the third power. And once I do that, I divide by 3. And there's my volume, 179.6 inches cubed. Alright, let's take a look at the next one. We've got a diameter of 4.2, so we're going to write out our formula. 4 pi 2.1 cubed divided by 3. 2.1 is our diameter, or I'm sorry, our radius. It's half the diameter. Alright, so let's take a look. We're going to put that in as 4 pi 2.1 cubed divided by 3. 38.8 feet cubed. Alright, that's it for area. The only surprises or things to watch out for would be the difference between height and slant height, and paying attention to the area of the base of that particular figure. Thanks, guys.